Good morning, dear students. Welcome to the new session of Standard 8 Physics, Chapter Sound, Part 3. So, dear students, today we want to discuss about the basic properties of sound. The properties are amplitude, wavelength, frequency, and time period. The first one, amplitude of sound. In words, you can say that it is defined as the amount of maximum displacement of vibrating particles of the medium from their mean position. So just consider this waveform. We know that sound in the form of waves. So just consider this wave, a sound wave. This line is called line of zero disturbance, means normal condition, there is no vibrations or oscillations. So when a body starts oscillate or vibrate, waves are formed there. And in such situation, how much the wave is displaced from its mean position. This is called mean position. So how much a wave is displaced from its mean position. And that particular thing is what we call amplitude of the wave. So this upper portion is called crest and the lower portion just below the line of zero disturbance or mean position is called trough. So crest and trough. And now the amplitude means what? It is the displacement of vibrating particles of the medium from their mean position, or how much a wave is displaced from its mean position. So it is what this point is what we call the amplitude. This is the maximum height or maximum distance or the maximum displacement. So you can say that this maximum height or displacement is called amplitude of the sound wave. And the SI unit of amplitude is meter. And normally it is denoted by the letter A, capital letter A. It is about the first property, amplitude. Clear? Yes. The second property is called wavelength. Then what do you mean by wavelength? It is defined as the distance between adjacent crests or troughs. Crest, here two crests are there, and trough, right? So the wavelength is defined as it is the distance between the adjacent crest or troughs. Clear? Yes. So this distance is what we call wavelength. The distance between adjacent crest or adjacent troughs. Clear? And this is what we call wavelength. And the SI unit of wavelength is also meter, and it is denoted by lambda, and this letter is called lambda. Clear? Yes. You just consider a wave like this, a sound wave. Then upper portion means the region above the line of zero disturbance or the mean position is called crest, and the region below the mean position is called trough. So the distance between the adjacent crest, that is very important, adjacent crest or adjacent trough, is what we call the wavelength. It is denoted by the letter lambda, and the SI unit is meter. Clear? Very simple. Yes. The next property, that is frequency. Then what do you mean by frequency? The number of oscillations per second is called the frequency of oscillation. So just consider a sound wave like this. The first case. One oscillation means starting from this position and ends at this position. And this is what we call an oscillation. Again, the second oscillation starts from this point and ends at here. The third oscillation starts from this point and ends at here. So like this, the number of oscillations that produced in a second is called the frequency of oscillation, or simply the frequency. Number of oscillations produced in a second is called frequency. That is why I gave different colors here, red color, blue color and green color. Clear? Yes. So in the first case, the number of oscillation means 3, means the first wave, second wave and the third wave. So number of oscillations produced in a second in the first case is 3. normally the frequency is expressed in hertz and it is denoted by Hz, hertz. And the frequency is denoted by the letter F, small letter F. So two cases are here. In the first case, the number of oscillation produced in a second is 3. In the second case, the number of oscillation produced is only 1 because the wave starts from this position and ends at here. So only one wave is produced in this case. Clear? Yes. Dear students, another important property is that time period. What do you mean by time period? It is defined as the time taken to complete one oscillation. Again, you just consider a sound wave and starts from here and ends at this point, right? So it is defined as the time taken to complete one oscillation. So one oscillation means starting from this point and ends at this point. This is what we call one complete oscillation. So you can take from this position to this position as the time period, or you can take these two peak. Both are correct. This is what we call time period of the oscillation. So time period is denoted by capital letter T and the SI unit is second. Very simple, second. So this is about the property time period. Clear? Yes. Dear students, in the previous slide you may have seen these two terms, loudness and pitch. Then what do you mean by loudness and pitch? Actually, these two terms related with amplitude and frequency. Loudness is related to the property amplitude. Means when the amplitude is high, it will produce a louder sound. Amplitude means what? It is the maximum displacement of the wave from its main position, and in such a way, when the amplitude is high, it will produce a louder sound. At the same time, when the amplitude is low, it will produce a soft sound, which means that the loudness of the sound is directly proportional to the square of its amplitude. Means if the amplitude increases, then the loudness of the sound produced also increases. If the amplitude decreases, the loudness of the sound also decreases. Clear? Yes. The term pitch, it is related with the term frequency. The pitch would be higher if the frequency of the sound is high. Frequency means what? It is a number of oscillations produced in a second. That is what we call frequency. And the pitch would be very higher if the frequency of the sound is high. And the pitch would be lower if the frequency of the sound is low. So these two terms are also very important in the section of sound. Clear? Yes. Dear students, the properties that we discussed today is very important in this chapter. So you must study all these points and relate all these terms together. Clear? Yes. Dear students, after watching this video, you may please go through the textbook and study each and every point that is given in the textbook. Thank you for watching video.